And in this video, we're going to be going over functions in C++. Or we're going to go over how to declare a function, how to make a function, and how to properly initialize a function. Now, as you can see, now in your C++ learning, you know that every function, every C++ program must have a main function. And the main function is needed because that is what the C++ program looks for to run. Now, it is possible to have all your code inside a main method. It's possible you could have a million-line main method. You could have a main method that has 3 billion lines of code in it, and that would be okay. It would run just as it would run and do all you wanted to, and it could work. But in a lot of coding day, when you have a huge program where maybe multiple people are working on it in a huge corporation, or maybe just you and a buddy, it's very good to separate your logic. So, for instance, if you have a bug, you can also break it down and look at different components of your code to find that bug instead of looking through one huge main method, as you'll see. So, breaking your code into parts is very good. You want to have loose coupling and high cohesion, which are just coupling is a term for how closely a program is put together, or how closely linked parts of programs are linked together. And so you want it to be loosely coupled. You want parts to not know about each other, figuratively, ideally, so that you can separate each part, and maybe somebody can work on the whole part so people can work at different parts at different times, and then just put it all together at the end, and hopefully it will work. And cohesion refers to how much the program belongs together, how they all work together as one, even though in coupling they can be different parts. So having loose coupling and high cohesion is very important. But anyway, let's get into how to essentially make a function. So as you can see here, I have my main function. And let's say I'm going to make a simple square function. So I'm going to make a function that you pass it in a number, and it returns the square of that number. And the square of that number is that number times that number. So we're going to do that for ints. And so the first thing I'm going to do is I'm going to declare my method. I'm going to make a method header. And what I do for that is, the first thing I need in my method header is I need a return type, if I wish to have a return type. Then I need the method name. And then I need the possible parameters. And it's possible to have no parameters, or it's possible to have unlimited parameters. So my first thing I'm going to do is the return type. The return type I want to return an int, because I'm going to square an integer and return it. So then I need to think of the name. I'm going to call it square number. And then I'm going to, do I need a parameter? Well, I need the parameter because I need to know the number I'm squaring, so I'm going to call it int num. Okay, and notice, so I have my return type, which is int, then I have my square number, which is the name of the method, and then I have the integer, then I have the parameters, and the parameters are always in parentheses. Just to note, if I did not want to have any parameters, so let's say I just have a method that is called print hello, and I just want to print hello, then for instance I would have no parameters. So then I could either put void here, or I could put nothing here. But I do need to put the parameters. So parameters with absolutely nothing in them. And that's okay. You can put void or leave them blank. They both actually do the same thing, just void may be a little bit more clear. But actually, I think leaving them blank is pretty clear as well. So that's okay for now. But like I said, I'm just going to Control Z and go back. And I'm going to have my int num, because I do need a parameter. And so when I declared int here at the top in my first word, I'm saying I am going to return an int. I'm making a contract with this method saying, hey, the square number method will return a integer. I could say return 0, that's an integer, but I'm promising that somehow I am going to return an integer no matter what. Okay, so in this case I'm going to return num times num, right? And that's all I want to do. So the return keyword is a reserved keyword again in C++, as you can see. And what the return keyword says is that it is going to return whatever you type you pass it in. So this method will return an integer, and I can use that integer in my function. So now I'm going to go up here to my main method, and I'm going to call square number, and I'm going to pass it in 7. It's okay if I passed in 7, or I could make int var equal to 7 and pass it in 2. Var and just the number 7 are both integers, so that is a valid process. So I can call in square number, and then I can build this program. And let's see, what do I get? I get a little bug here, and it says use of undeclared identifier square number. So what that means, and hopefully if you've been paying attention in class you understand this, is that it does not know about square number. And what's happening is when I'm running this program, when I'm compiling it, I didn't even try to run it, my program is going from top to bottom. So it goes to include iOS stream, and it goes, oh hey, I need the IO library, which stands for input output, and then it uploads that, and then it goes to the standard library, and it says, okay, hey, I need that, and so it uploads that, and then it goes into my main method and says, okay, I got this variable, and then it says, oh, square number, where is that? Oh, I don't know where square number is. I never loaded in a square number. So that's an error to me, and so I'm going to stop there because that is an error. So what happens is the compiler doesn't know about this square number method, even though I have it defined there. And what happens is I need to define square number before I reach square number. Now, just to show you guys quickly here, one thing I could do, which is very bad practice, very bad, nobody wants to do it this way, is, my bad, I was playing Game Boy. And, okay, so one thing I can do is I can paste square number up here. So what happens is now is that when the computer reads this, hopefully when I build this, my error goes away. And what is it saying? Undeclared identifier square number. I think that's okay. So what I did here now is I put square number here, so when the computer reads through, it loads the library, it loads the standard library, then it gets this square number method. It says, okay, there's this square number method which returns a square. It doesn't really matter. I know about that method now. So then I go to my main method, I see my int var, and then I go, oh, square number, I know which method that is. That was the method I defined up here, which is pretty cool. So let me see. And when I run this program, when I run this program with 7, I get 49, which is the correct answer, right? 49. So as you can see here, that's pretty cool. So another thing I want to illustrate, it's giving me a warning here because I didn't use var, I just put it up there because I could pass in var or 7. And I can just run the program to show you that it's always causing me stupid problems. And it gives me 49. So that's pretty cool. But something else I want to show you guys is I wanted to make it very clear is that I am returning an integer here. I am returning an integer. var is not, the value of var is not changing to 49. I am passing in var and changing a calculation on it. For instance, if I print it out, you know what, let me just do a cool thing here. What I'm going to do here is I'm going to print, if I print it out var here, I'm still going to get 7, and I printed out a new line. So new line, and then I'm going to print var is, going to build it, then I'm going to run the program, save it first, then I'm printing out, I print out 49, and var is still 7. So I didn't change the value of var. I passed in var, and then it returned num times num, and did that. And another thing I want to illustrate is, let's say I calculate, I do square number here, and then I print out var down there, and I forgot my semicolon because I'm not good at this keyboard. And so let's say I called square number here, and then I printed out var later on. Doesn't really matter that I have that new line, but if I did that, I get 7 here. And so you see here, I see this mistake happening a lot, is that I have square number here, and then I called square number, and so it returned 7 times 7, or whatever I passed into. It returned 49. But see, now what happens is it returns 49, and I have this value 49 on this line right here, but then I'm not doing anything with 49, and then I go to this line, and 49 is gone, because square number is returning a number. It's returning, whatever the square is, but I have to do something with it. I have to take whatever that is and assign it to something. So square number will return a number. So think of a square number saying, hey, give me 49. You can almost think of it as an alias for 49 or whatever I pass in now. But now that I have that value, I need to do something with it, print it out, or keep track of it, or assign it to a variable, so then I have that variable permanently. For instance, now if I run this program, I get 49 because I assigned whatever square number returned to var. And another mistake I see beginner programmers make is when I'm passing things into a method, format that, I do not put int here. I do not put int here like in the method header up above. That is a big no-no, okay? I just pass in var. I have to give it integer up here because I need to tell it, the compiler, what types it should be accepting. But then I just pass in the correct types in the correct order to do so. So just make sure, don't have int here or anything. You should have int in your method, because you're defining the method here, and then you're calling it later. So when you call it, you just want to pass in either your constants or your variables. No int or anything like that. That's a very common error I see. And so that's another thing. But now I showed you guys, I also, in the beginning, I told you guys to do this very bad practice of putting the method up top. And what we really want to do is you want to have everything below your main method. And we are now going to make a method header at the top. And what the method header is here is it's just this line that I made with square number with a semicolon at the top. And so what this will do is this will allow my program to compile as well. Give me an error there, but there's no error there. And so if I print it out, I just get 49 again. I'll leave that right there. And so what this is doing is this is the same thing as putting the method up top, but it's much better practice, and this is what the pros do, and this is what you should do too, is that I have this is called my method header here, my method declaration, and that I'm telling the compiler that this method exists. I'm saying, hey, there's a method called square number, takes an int, returns an int. Okay, just be on the lookout for it. So then I go through my main method and compile it, and I see this method square number, and I say, hey, square number, I was told about that up here. So then I look down in my code, and I can, maybe if there's more methods, I'll look through them and I'll say, oh, hey, here's this square number method. Let me link them together because they're looking at the same thing, they're the same types, and they're the same method. So now I know to link them together and I don't get any errors. So that's why it's very important to have your method declarations. Now it also is good practice to put them in an H file sometimes. And what an H file does is, let me open my folders here. What I'm going to do quickly is I'm going to make a header file, and I'm going to call it test1. I'm sorry. Test1.h. So now I have this header file right here, and this is pretty cool. And I like to put a few little words before it, but I'm actually not going to show you guys that right now because I decided not to. And something you can do that's really cool is you can put, let's say I have multiple functions, I can put all of these in my .h file, and what the H stands for header, CPP stands for C++, CPP. Hope you guys get it. And so what I'm going to do here is I'm going to have a header file that I just created here in my second bar, and I've got my testing CPP file. And so in my header file, like we've done, is I'm going to put my method declarations in that header file, and then I'm going to tell my C++ file about this test1.h. And the reason, because I need to tell that, I need to tell it about that test1.h is because I need the compiler to be able to link the header file with the testing CPP file. So what happens is, when I go through this include, I include the IOStream library, and then I get to this include, the include test1.h, and so that includes this whole file. And so you can actually think of this include as a total copy and paste of the same file. So when the computer runs by this library, it's printing out, it's copying the whole IOStream library and just pasting it like all right here. Except, you never see this happen. And that's the same thing that's happening when I'm including this test1.h right here. It's pasting in this content for me to look at. So that's pretty nice. So then it pastes that content, so then it knows about the square number and everything works the same as it always did. But I was able to create separation, so in case I have a lot of method headers, I can put them in a separate file, and everything is nicely contained and put out and made easier to look at. So if I can separate my method declarations and functions, so I don't have it all in one cluster. So that's pretty cool. And notice here how the IOStream has brackets around it, and the test1.h has quotes around it. For brackets, the brackets are used for when you have a system file. So IOStream and the main C++ libraries, IOStream, string, fstream, IOmanip, are things of that nature that are declared in the system C++ files, and in quotes means a computer file which is declared on your computer, so like test1.h. So that's pretty nice. So like again, just to show you guys, I'm going to build this program and I'm going to run it just to show you guys that nothing has changed. I'll make this 9 now. What's 9 squared? I believe it's 81. Never sure though. Okay, so 81. I think that's right. I'm pretty sure it's right. I have some kind of college education. I should know this. Okay, so there you go. So I hope this cleared up a lot of things about functions for you. Actually, one more thing I'm going to go over that I just remembered is void. So remember, you can have a void function. So another thing about void is, let's say, okay, so sorry. So in my return, like I showed you guys in my return types, I'm getting too ahead of myself. In my return types, just like here in my parameters, I can have anything. I could return a char, I could return a string if I include it in the libraries up there. I could include a double, I could return a double, I could return a float, I could return everything every type that you know of. But also, what if I don't want to return anything? What if I have a say hello function? So, like I said in the beginning. So right now I'm going to make a function called say hello, and I'm going to declare it void. And what void means is that I am not going to return anything. I'm making a contract that I do not need to return anything. And so let's say I do that. So I'm going to print something out, and my phone is ringing. I'm going to print out, hello. And we'll put a nice endo right there. Okay, so I'm going to print out void say hello, and then I'm also going to put the method declaration in my H file with a semicolon at the end. Don't forget that. And so there you go. I am saying void say hello. Now note, it is also in, I will quickly say this, in the say hello method, it is okay to say return blankly. It is okay to say return with a semicolon immediately following it. And what that means is that to exit out of the function. If I just put a return, that means to exit out of the function. So for instance, let me put, to show you guys, I'm gonna print out hello twice. But what's really going to happen is hello twice will not be executed because return, I need to make this an integer, return will stop the function and it will exit, and only hello will be printed out. So let me recompile this program, and actually, what about instead I do say hello right there, and let's run this bad boy. It's probably going to ask me to save again because I never save. I think I'm getting an error somewhere. That's why this is taking forever. Oh, because guys, I am a dum-dum. And all I need to do is do print say hello on its own because I'm already couting it in the function. And as you can see here, I printed out hello. hello, not hello twice like you see right there. And if I got rid of this return, hopefully both of these would print out. Hello and hello twice both printed out. So that's pretty cool. So that is something important to understand. I can have no parameters, and I also cannot return anything, but if you return something, make sure that you're using the value it's returning. Also, if I just quickly, if you want to have multiple parameters, so let's say I just want to have more than one parameter. For instance, if you want to add anything, any addition requires 2 parameters. So let's say if I want to do, I'm going to end the video soon, but let's just say I'll just make a double called param2, and then I can do a float param3. So there you go. I have 3 parameters, and I could keep going on and on and on and on and on and on and on, which is pretty cool. So that's another way. There's a ways to declare multiple parameters and things like that. I hope you guys enjoyed this video, and I hope you guys have a great day.